Today we're going to start with section 3.5, and this is a fraction of a set. So this is, so let's look at fraction of a set, and this is section 3.5. Okay, so let's say we have a situation that you have some children, and out of every 5 children, 2 are girls. Okay, so here are girls, so there are 5 children, and out of every 5, 2 of them are girls. So let's look at this. And then, so there are 5 children, and the girls are the multiplication symbols and the plus symbols are the boys. Then you have 2 girls, and then you have 3 boys. So out of every 5, so you pick these 5. So now the way that we say this is, 2 out of 5 are girls. 2 out of 5 children are girls. Right? Okay. Another way of saying, so this is more like explaining terminology. So agar aapko kahun 2 out of 5 children are girls, right? So this is this physical situation. Okay. Another way of saying the same thing is, we can say 2/5 of the children are girls. 2/5 of the children. ये मैं English की बात कर रहा हूँ. How do we say things in English? 2/5 of the children are girls. So why does it make sense to say something like this? Well, the reason why something like this would make sense is that what we're thinking of it is that we have some children. This whole is children, and we're going to break it up into 5 equal pieces, and we're going to take 2 out of those 5 equal pieces, and those will be the number of girls. Okay, so let's think about it. So this is what we mean. We have, let's say we have 15 children. In this case, remember we have 3 5s, so this is 15 children, right? There are 15 children, and these are the girls, and plus would be boys, right? Okay, so maybe I shouldn't put a bar, I should put a comma here. Okay, so now let's make our model. So this is the total number of children. Now we have to consider, so remember we have to break them in 5 equal pieces, and equals meaning is whatever meaning we want to give it. So in this case, what would equal mean? Equal in terms of what? Equal in terms of? Yeah, numbers of children, the number of children, right? Do you understand that? This would now be equal in terms of the number of children. So let's break it up. 1, 2, doesn't look equal, but we'll try. So 1, 2, 3, 4. This is smaller. This may be a bit bigger. Okay. So 4 and maybe 5, something like this. And now, so we have 15 children, and we have to divide it in 5 equal pieces. So that means we know that 15 divided by 5 is 3. So we're going to add 15 divided by 5, which is equal to 3, which means each piece is going to be 3. So each piece is 3, and this is just caring about the number of children. There are 3 children in each box, and what we mean by this is that 2 of these boxes, so if we look at the number of girls, there will be 6 girls and hence there will be 9 boys. Okay? Okay. Any questions about this? Yahan tak. All good? Everything is? Yeah, please.
Matt, you're saying that in every box there's 3
Children.
children. And like they're in groups of 3 now.
Yeah, because you see we wanted to figure out what does 2/5 of the children mean in terms of now the number of children. So we have a total of 15 children. Since we want 2/5, we have to find out what 1/5 is. Right? We have to first find out what 1/5 is, because 1/5, you see, this is 2/5. So if I write it out, remember, this is 2/5, right? Just like 2 apples. So I have to find out what a 1/5 is, and then I have to take 2 of them. So I first found out what a 1/5 was. A 1/5 is, you take a whole. When we have a part of a whole interpretation, you take a part of a whole and you divide it into 5 equal pieces and you take one of them. So I took a whole in terms of numbers, which was 15, and I divided it into 5 equal pieces, so each piece got 3 children. So I put 3 children in each of the pieces and I took 2 of them. Is that your question?
Yeah.
Okay. Okay. So now, so we know 2/5, so the girls, so 2/5 of the children, so we know 2/5 of children is equal to 6 children, right? We just figured it out. But let's say how did we calculate it? What we did was we first divided 15 by 5, right? That's the first thing that we did. We divided 15 by 5, and then I'm going to use something called parentheses. So these are parentheses, and so in general the rule is that whatever is inside the parentheses has to be done first. Okay, so parentheses means do this first. So we are going to divide 15 by 5, and then we are going to multiply it by 2. So what, sorry, I should have stated it here. So what I mean is, the way that you calculate 2/5 of 15 is, you take, so first you are going to divide 15 by 5, right? And then you're going to multiply it by 2. Agreed?
Yeah.
So what we're trying to do actually is we're trying to figure out what does 7/5 of 39 mean or something. That's what we're trying to do. We're trying to understand the meaning of. What does fraction of a set mean? In this case, it was a set of children, of 15 children, exactly. It was a set of 15 children that we were dealing with. Okay, so this is 2 times 15 divided by 5, and now, so what we can do is, remember what is 15 divided by 5? I'm going to write down some series of funny things. How can we write it as a fraction?
2
Multiplied by?
3.
No, that's the answer. 15 divided by 5 is 3. How do we write 15 divided by 5 as a fraction? Remember, it's the division interpretation of fractions?
15 over 5.
15 over 5, exactly. We write it as 15 over 5. Okay. Now let's start thinking. Let's say, so you see this number, right? You see this 2 multiplied by 15 divided by 5. Here's another story that I can tell you. You have 2 aunts, okay? And there are 5 children, okay? And each aunt has 15 candies to give, and she's going to come and distribute the candies equally to each child, okay? So the story for So I'm going to write a story here. So this story, so here's a story. 5 children have 2 aunts. 5 children have 2 aunts. Each aunt is carrying 15 chocolates. Each aunt has 15 chocolates to give. Chocolates to give to the children. To give to the children equally, or to equally give to the children. I don't know. To give to the children, if each aunt, okay, whatever. So equally to give, and I'm going to just write it in parentheses, equally. So she is going to give them equal. Each one of them is going to give them equally to each child. To the children, how much does each? How many chocolates? Here's the question. Same mathematics. How many chocolates does each child get? Okay? So remember, 2/5 of 15 we figured out was equal to 2 multiplied by 15 divided by 5. But 2 multiplied by 15 divided by 5 is the answer to this question also, right? So let's see. So now what? So now which is equal to this, right? So one way is that so I'm one aunt, there are 5 children here, I come and I give 3 chocolates to each child. And now the first aunt goes away, the second aunt comes in, and I'm going to give 3 to each child. That's one way to do it. The second way to do it is, here's one aunt, here's another aunt. Aunt number 1, aunt number 2. 2 aunts standing in front of you. They pool their chocolates. How many chocolates?
30.
Yeah, it is 2 15s. And then once they've pooled the 30 chocolates, they equally distribute to each child. That's another way to think about it. Anything wrong with that?
No.
Nope. So that means, what that means is, so yeah, we're trying to be very careful. So there's a series of equalities, right? So we can say 2 multiplied by 15 over 5 is the same as 2 multiplied by 15 divided by 5. Anything wrong with that?
No.
Same thing, right? Okay, that's good. Now,
So you're saying that they're just 2 different ways of doing the same thing?
yeah, they're doing the same calculation, right? There's exactly the same calculation. There's no different ways of doing this. Okay? And what is this equal to? So, sorry, but what's this equal to? So I should have written something more. So I'll start out with this. I'll say 2 multiplied by 15 divided by 5 is equal to 2 multiplied by 15 over 5, which is equal to 2 multiplied by 15 over 5, which is actually equal to, what do? You multiply first and divide later. So I'm going to multiply first and divide later, right? Do you see how the parentheses have shifted? We were dividing first and multiplying later, but now it's the same as multiplying first and dividing later. Okay, we're learning that important thing, that whether if you just have multiplication and division, you can do division first, multiplication later, or multiplication first or division later, if you have it in this way. Okay. Now let's do a completely slightly different thing. It may not be directly related to what we were doing, but and it will get related to it in a second. Let's look at another thing, and I'll write it over maybe here. Okay, so let's look at 2 over 5 multiplied by 15. What does that mean? I mean, so now I'm thinking and I don't know what this thing actually means. It is 2/5 multiplied by 15. I know what 2 15s are. That's 1 15 and another 15. So I can add up 2 15s and I'll get 30. That I know. But I don't know what 2/5 multiplied by 15 mean. Right? So this is something that I don't know the answer to. Is this clear?
Yeah.
Okay, if I ask you randomly what is 2/5 multiplied by 15, you will say, I don't know, it doesn't make sense, because remember, multiplication, what was the meaning of multiplication?
Multiplication is
Repeated addition. But how do I repeatedly add 15 2/5 of the time? I don't know what it means. I can add 15 2 times, 3 times, 4 times, 5 times.
If you do 2/5 plus 2/5 plus 2/5 plus 2/5.
No, that's something else. That's 15 2/5. We're going to get to it in a second. This is add 15 2/5 times. That's a weird interpretation, right? So the first important thing that you need to realize is that we are breaking down with our, so this is the multiplication. Multiplication is repeated addition breaks down. अगर हम सोचें तो multiplication as repeated addition, is that true still? No, I don't know, because otherwise I won't be able to define it. How do I add 15 2/5 times? So this idea is getting broken, right? Multiplication as pure repeated addition. If I have 3 4s, I have a 4 and a 4 and a 4. I can add 4 plus 4 is 8, 8 plus 4 is 12, and I know 3 4s are 12. That makes sense. What does adding 4 2/3 of the times mean? If I say, let's say if I say 2/3, if I say 2/3 multiplied by 4, what does it mean? I know, or right, I don't know what, I know what 2 4s means. 2 4s means just as repeated addition 4 plus 4. So this works. But I don't know what 2/3 multiplied by 4 means. Is that clear? Yeah? Okay. So now we use your idea, which was a nice idea. You said, I don't know what 2/5 multiplied by 15 means. That's weird. I mean, that's, so this is really our, so this is what we are worried about, right? I mean, this is our sort of cause of concern. We are worried about this issue, right? Do you understand the issue? Yeah? Yeah, nahi?
Yes.
Is it clear?
Yeah.
Okay, we can't repeatedly, I can't say 2/3 of 4, so I won't write 4 fully. I'll write a smaller version, maybe a broken down. I'll take 2/3 of, this is 2/3 of 4, and I don't know what this means even, okay? It's a silly, stupid idea, so I'm not even going to try to write it down. I'll leave the question mark here, and I don't know the answer. So let's try a different version here. So we know, but we know, as you stated, what 15 multiplied by 2/5 might mean, right? So I'm going back to this. I don't know what 2/5 multiplied by 15 is, but I might know what 15 multiplied by 2/5 is. This is 15 2/5. That's something which I know, right? It is 2/5 added how many times?
15 times.
15 times. That I know how to do. That's easy. That interpretation can still hold, right?
Yeah.
So this is 15 times, right?
Yeah.
So what would the answer be? If I add 2/5 15 times, that's just going to be 15, because I add 2 plus 2 plus 2 plus 2, that's how you add fractions. It's just going to be 15 2s over 5. Agreed?
Yep.
Okay. And now what I'm going to do is, remember our friend the commutative law? So remember the commutative law, right? So if I'll just repeat 4 3s, so this is the commutative law. So remember, so we have our old friend, the commutative law. So we have lots of good friends. The commutative law of multiplication. The commutative law of multiplication. So what was our old friend? The commutative law of multiplication. That was that if you have, the order doesn't matter, and let's say you have so now if you look at it vertically, you have a 3, you have a 3, and you have a 3, and you have a 3. So that means you have 4 3s. This is 4 3s. But you can look at the same thing horizontally, and now if I look at the same thing horizontally, this will look like, very bad drawing, but I hope you can see it. You can see a 4 and a 4 and a 4, and you see 3 4s. So this turns out to be equal to 3 4s. The order does not matter. Okay? Now we can wish this law to be true for fractions also. Okay? I'm not trying to, so I'm not saying this is true. Oh, I'm going to leave this interpretation, sorry. Children have two, terrible, okay, don't overwrite. Have 2 aunts, right? I think that was the question. Yeah. Okay, so let's require the commutative law. So now let's require the commutative law. We are not proving it, which is different, right? We like the commutative law a lot. Require the commutative law for fractions. So if we say the commutative law must be true for fractions, so फिर क्या होगा true? So then what will turn out to be true is, we have just defined, our addition interpretation, repeated multiplication is repeated addition, allows us to define 15 multiplied by 2 over 5. But if 2 over 5 times 15 is equal to 15 times 2 over 5, then we've also figured out the answer to 2 over 5 times 15, right? So what that means is, so this is an equality, but it means something slightly different. 2 over 5 times 15 is equal to, and this is really our requirement. This is something that we are imposing on mathematics. We would like it to be true. We can, there are other laws that force it as well. But, so we can look at other laws like the distributive law, and that also forces us into this thing. Again, I'm just giving you one reason why this ought to be true. So if you want the commutative law to be true, then this better turn out to be equal to 15 multiplied by 2 over 5. Okay? This is what we are imposing, the commutative law of mathematics that we want to be true. We proved it to be true for numbers, whole numbers, but now we like it so much, we say we also want it to be true for fractions. So if you want it to be true for fractions, then this number turns out to be equal to this number, which turns out to be this number. Agree? Yeah. Okay. So now, given this story, we have a long story on the board. I'm sorry, this looks really horrendous, but okay. So now look what that's the story we have. We have, this was, remember what this was? This was, we had 2 multiplied by, we had 2 aunts, and each one had 15 chocolates, so 15 divided by 5, which was, this was the number which was equal to this, which was equal to this, right? Which Now this turns out to be equal to this, right? So I'm going to erase this part of the board. Okay, so let me erase this part of the board, and now let's come to the real meaning of the whole thing. I mean, we have spent a lot of time with ants and chocolates and everything. So now what I can say is that 2 over 5, so what can I say? I can say lots of things. So I can say, let me start from here. I can say 2 multiplied by 15 over 5 is equal to 2 multiplied by 15 over 5, which is, yeah, it is always equal to that, which is equal to, absolutely right. So this is equal to, or 15 2s or 2 15s I'm ignoring, but you're absolutely right. So this is also equal to 2 over 5 times 15, which is also equal to 15. So let me do it. So this is equal to, maybe I'll write it out if you want to, 15 multiplied by 2 over 5, which is equal to 15 multiplied by 2 over 5, which is equal to 2 over 5 times 15. All of these things are true. And now one of these equalities is imposed. Which one of the inequality was really a requirement that we didn't prove?
15 multiplied by 2 over 5 multiplied by 15.
Yeah.
Is equal to
2 over 5 times 15. This equality is what is slightly different. We proved this is equal to this, right? And this is equal to this by the commutative law for whole numbers. And this, we showed these two are equal because of the multiplication is repeated addition interpretation. But this is what we imposed. This is the commutative law, wanting the commutative law. So this is want commutative law, want commutative law. Okay, this is really what we want. Agreed? Okay. Now let's think about the ants, the poor old ants. Let's think about them in a different way. So now what we can do is, we have ants and they are carrying 15 chocolates each. So let's look at the 15 chocolates. They're very nice chocolates. Here are 15 chocolates. Nice looking bars, and 15 chocolates here. And so there are 5 children, right? So if I think about 5 children, I can break them up into portions of 3 chocolates each. 1, 2, 3, 4, 5. So this is aunt number 1. This is aunt number 1, and here's aunt number 2. And aunt number 2 also has 15 chocolates, identical ones. So they look a bit fatter. Children would prefer this chocolate. Okay, so here, 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 here. Okay, so these are, see, they're the 15 chocolates of these aunts, right? So now you can see each one of these, there are 5 equal pieces, so that means each one will contain 3, right? Because there are 5 equal pieces. And now what the aunts could do is that we can imagine another thing. Remember, what we could do is we could imagine 2/5 of an ant. So how much would 2/5 of an ant be carrying? Well, you could imagine 1/5 of an ant from here and 1/5 of an ant from here. So here's 1/5 of an ant from here, and 1/5 of an ant from here. So we could dedicate this ant to one child, and that child would be getting 2/5 of the whole booty. Sorry, only 1/5 of the whole booty. Sorry, not 2/5. They would be getting 2/5 of all the chocolates.
Yeah, but 1/5 from each aunt.
Yeah, 1/5 from each aunt. let's think about the meaning of this equality. I can do it in two different ways. One is something that we are going to do in chapter, which chapter? We are going to do it in this areas chapter. So this is in chapter 7. So there's one answer that I can give you. Why do we believe in this equality? That's the question, right? That's what we are worried about. This equality we don't like, right? So one answer is, one answer is going to be in terms of areas, and this is going to come in chapter 7, okay? So we'll talk about this again in chapter 7 in this book, okay? So that's one answer that I could give you. Why do we want this equality to be true? Let me try another method and see if that works. So this is method 2. So the method 2 is going to be, let's think of a number like 1 multiplied by 15, we all agree is 15, right? That nobody hopefully doubts. 1 times 15 is 15. Now let me, and you hopefully also agree, that 2 over 5 plus 3 over 5 is also 1. Do you agree?
Yes.
This is just 1. So I'm rewriting this as this. So let me rewrite this in a proper way. So 1 times 15 is 15. So I can write 1 times 15 as 2 over 5 plus 3 over 5 multiplied by 15. Do you agree? Okay. Now you may know something about the distributive law. Remember things like this. So here's a story that if you have, I have 2 baskets. So do you remember the distributive law? So let me, if we want the distributive law to be true, if we want the distributive law to be true, if you want the, and we'll see why it is important again जब हम areas देखेंगे, the distributive law to be true. Distributive law to be true. So do you remember what the distributive law was? No. Okay, let me just try to answer it here. So remember this equality, that's the only thing that I'm going to explain, nothing else. So the distributive law is something like this. So here's a story. Let's say you have 3 baskets contain, so you have 3 baskets. So here are 3 baskets, right? And each one of these baskets, so they're lying on a table. They're lying on a table, this is a table, and each one of them contains 4 apples. Okay? There are 4 apples in 3 baskets, they're lying on a table. And here's a chair, I can make a chair, here's a smaller table. Here's a small table. Okay? Oh, they're not even on the same ground, so let me make the big table. And here's a small table, and there are 2 baskets here. They also contain 4 apples each. Okay? So we want to count the total number of apples. There are 2 ways to do so. One way is that there are 3 baskets here and 2 baskets here. So how many total baskets? 5. So we could say this is just equal to 5 fours. That's one way to say it, right? Or a different way to do it is we could count. So I'm going to tell you. So this is just equal to 3 on the big table and 2 on the small table. So let me write it out here. So this is going to be 5 times 4. That is just equal to 5 times 4 is just equal to 3. That's obvious because I have done nothing yet, right? 5 times 4 is just equal to 3 plus 2. But then I could count the apples on the big table first, which is 3 fours. And I could count the apples on the small table later. So this is the distributive law. So this law is the distributive law. That when you have parentheses and you're adding things and you have to multiply, then you can multiply first and add later. Is this clear? You added first and then multiplied. यहाँ पे you're multiplying first and adding later. So it's 3 times 4, which is 12, plus 8, which is 20. Agreed? That's a distributive law for whole numbers. Okay? Now here I'm saying something else. If you want the distributive law to be true for fractions, right? We proved it for whole numbers. I'm not trying to prove it for fractions. Remember, it's the same kind of argument. We didn't prove the commutative law for fractions, but we said if we want the commutative law to be true, then the meaning, then 2/5 of 15 better turn out to be 2 over 5 times 15. Now we are making a similar argument. If we really, the associative law is a very powerful law. Sorry, the distributive law is a very powerful law. If we want the distributive law to be true for, which is true for numbers, that is easy to prove. If we want the distributive law to be true for fractions, then what do we have to do? We have to define it to be equal to, if you want the distributive law to be true, what has to be true?
2 over 5
Multiplied by 15.
multiplied by 15.
Yeah, it's going to be, yeah, that's what we would like to be true again, right?
Plus 3 over 5 multiplied by 15.
Right?
Yeah.
Okay. And now, we don't know what the meaning of these things are. We are just dealing with symbols right now. Okay, हमारे पता ही नहीं है इसका क्या meaning है. But let's assume what we did over there for the commutative law. Remember? So multiplication का क्या मतलब था?
Repeated addition.
No. Repeated addition हमने नहीं, हमने break down करके हमने कहा था this multiplication is kind of a weird multiplication. This is the multiplication which was based on the red equality. So I'm going to call this the red multiplication. It's not the white vanilla flavored multiplication. It's a strawberry flavored multiplication. So the strawberry flavored multiplication was 2 over 5 times 15 is equal to 2 multiplied by 15 over 5. Remember we did that? So what I can say is that the strawberry flavored multiplication is equal to 2 multiplied by 15 over 5 plus, so this is still the strawberry flavored, no, now this is a vanilla flavored multiplication, sorry, plus 3 multiplied by 15 over 5. We knew the meaning of this multiplication. This was multiplication by a whole number, 1 multiplied by 15. But we don't know the meaning of this multiplication. This is a fraction multiplied by 15. We don't know what it means. But अगर हमारी वो strawberry flavored definition सही है तो इसका मतलब ये है with the vanilla flavored multiplication back, because now we are multiplying whole numbers.
Yeah.
And remember, this we can write as 2 multiplied by 15 plus 3 multiplied by 15 all over 5, because this is just what addition of fractions means, right? But now this is again the distributive law of multiplication. So I can again say this is equal to 2 plus 3 multiplied by 15 divided by 5. Why? Because when you multiply, remember, हमने अभी whole numbers के लिए prove किया था with the apples and the baskets कि 2 plus 3 multiplied by 15 is equal to 2 multiplied by 15 plus 3 multiplied by 15. That's exactly what we have over there. ठीक है? It's just reversing the distributive law. Okay? All good? यहाँ तक ठीक है? So what's this equal to? This is equal to 5 multiplied by 15 over 5. And what's this equal to? 15. So you see, remember 1 times 15 kya tha? We started from here.
Yes.
So do you see that if we define our strawberry flavored multiplication as we did, then 15 turns out to be equal to 15. Right? This is this chain, right? 15 is equal to this, which is equal to this, which is equal to this with this weird strawberry flavored multiplication. But this is equal to this, which 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 is equal to 15. So that means that our definition of the strawberry flavored multiplication is not a terrible definition. It's a good definition. ये बात समझ आ रही है? So now what is happening is that the commutative law is boxing us into a corner. It is saying define, so this is what the commutative law says. This is a big law, a big fat law, big fat law, big fat law. This is a commutative law. It says define 2 over 5 times 15 to be equal to 2 multiplied by 15 over 5. That's what it wants. We don't know what it is. This is again the strongly favored multiplication. We didn't know what it meant. Okay, the big fat commutative law, this is the commutative law. Big fat law says define it this way. If I want to be true, hence define it this way. Then you got another big fat law. Okay, this is another big fat law. He's still fat. This is the distributive law. The distributive law also boxes you and says define it this way. Okay, there'll be other things that are coming in that are going to force you to define it this way. And you say, okay, this is the way that makes sense. Okay, so what happens is when you have a lot of laws all forcing you to define things in one way, then what happens is that's called the natural way. It's natural to define it this way. If you don't define it, terrible things will start to happen. And you will see, in fact, all of algebra would fail if we did not define things this way. So algebra is based on the commutative law, the distributive law, the associative law, all these laws being true. So everything is sort of based on that thing. And I'll also show you a very, when we talk about areas, that it's very natural to define this to be true. But you have to wait for it for a while. Okay? Okay, thank you so much. Any questions? Okay, great, thank you.